Okay, so we're going to go through just a handful of these. They should all be stuff that you've covered before. I just want to review them. All right, so the first is the concept, and all of the rules that we're going to go through here have rules that coincide with both addition and multiplication. Okay, so there's a closure rule. What the closure rule means basically is whatever subset you're using for addition and multiplication, the solution will be the same subset. And so if you're adding two real numbers, the sum will be a real number. If you're multiplying two real numbers, the product will be a real number. If you're adding two natural numbers, the sum's going to be a natural number. You see how the subset isn't going to change if it's the same for both things. So that's the concept of closure. It works for both addition and multiplication. Okay, this isn't really something that'll come up all that often. It's just something that the book presents, so I wanted to make sure you understood what it means. Okay, the ones that you do have to make sure that you can distinguish are commutative, associative properties. Okay, they're very similar to each other. The commutative property simply means that you are reordering. Either the terms or products or factors. And the generic way that this is identified is for the commutative property of addition. Okay, so, oops, I'll write it out. Right, so the commutative property of addition means that if you take the sum of two terms, it doesn't matter which order they're in, the sum remains the same. And so when you're identifying commutative property, the order changes. And the same holds true for multiplication. So the commutative property of multiplication means if you take two factors, two things being multiplied, so A times B, that product is the same as taking B times A. It doesn't matter what order you multiply those, they're going to give you the same overall product. Right, as kind of in comparison to that, the associative property, the order is not going to change. So that is the main difference. So in associative properties, the order is going to stay the same. All that changes is the grouping. Okay, so if something's just grouped differently, but the order doesn't change, that's referred to as the associative property. And this also applies to both addition and multiplication. Okay, so this has to involve three terms. So A plus the quantity B plus C is going to be equal to the quantity A plus B all plus C. So you notice that in each of those, the order of the terms is still A, B, and then C. The only difference is that the grouping symbols are around the different set or different pair of values. Okay, the same holds true for multiplication. If you take A times the product B, C, that's going to be the same as, again, no order change, just grouping change, the product of AB times the lone factor C. Okay, so that's associative property. Again, those are the ones that get mixed up the most often, so make sure that you can identify which is which with that respect. In addition to these two, there are identity and inverse properties of both addition and multiplication. So we'll talk about those here in just a sec. I'm just going to abbreviate this. So the identity property of addition means what do you add to something so that it remains itself, or it keeps the exact same identity. So what do we add to A so that the result is A itself? The number is 0. So that's the identity property of addition. The identity property of multiplication has the same kind of concept, except now we're looking at what do you multiply a number by so that it equals its original self. Okay, so those are your identity properties. And then the final property that we're going to apply to both addition and multiplication here is called the inverse property. Of both addition and multiplication. The inverse property of addition is basically saying, so what undoes, what property or what operation undoes addition? Subtraction. So the inverse property, the inverse of an addition is subtraction. Okay, so this is also called the additive inverse, is probably what you might know it. The additive inverse of A is negative A. And it's just the opposite. So additive inverse is another way to say opposite. Okay, and then on the other hand, the inverse property of multiplication. So what operation undoes multiplication? Division. So if you take a number and you multiply by its reciprocal, you undo that operation. So that's going to give you an overall value of 1 in this case. And this is referred to as a multiplicative inverse. And if I took the value, if I had a fraction as my original value, so if I had 3 over 4 as my A value, the multiplicative inverse is going to be just the flip side of that. You invert the entire fraction, so it would be 4 over 3. And this multiplicative inverse is probably more commonly referred to as reciprocal. All right, so none of these terms so far have been new, right? Except maybe closure, that concept, but hopefully everything else is something that you've heard before. All right, the last concept is one that it doesn't specifically apply as addition and multiplication. It's sort of a combination of those. And that is the distributive property, which again I hope that you are very familiar with. And the distributive property just means that if you take a factor A and you multiply that by a sum of terms, B plus C, then that factor winds up applying to both of the terms in that sum. So it expands out into the product AB plus AC. And again, we call that distributing. Right? But we go from a factored form into what's called an expanded form using the distributive property. You can also go the reverse process, like some books will teach it. Distributing can go either direction. So again, it doesn't really matter to me. It's usually in this direction, from the factored form into what's called the expanded form here. Right. So if I were to ask you to identify some instances of these, I'm just going to write a few very simple ones first. Okay, so as I write these, I want you to kind of see how would you describe each of these statements. All right, so looking at it, 3 times 4 equals 4 times 3. What would that be an example of? Commutative property of? Commutative property of multiplication. So again, I abbreviated here. You guys, if you're answering these types of questions, it'll mostly be a multiple choice. So you pull down the correct answer. Okay, what about the second example? 0 plus 8 equals 8.
Identity property of addition.
Good, identity property of addition. What can you add to itself so that it equals itself? Okay, what about the third example? Negative 7 plus 7 equals 0. Inverse property of addition. You add the opposite to undo the operation. And then finally the last example is good. Okay, so those ones are pretty straightforward. Hopefully you're able to just see them and quickly be able to identify what they are.